In this lesson, we're looking at transformations of exponential functions. So here we have the transformation rules for functions. So the first two right here, we have f of x plus k and then minus k. That is outside of the parentheses, and so that is a transformation up or down. So if it's positive, it is that many units up. Negative is k units down. For the coordinate grid, you're simply adding or subtracting, or the coordinate point, you're adding or subtracting your y value. So if it's a translation up, you add your k or whatever number or value that you're given, or you subtract it if it's a translation down. Next, we have the transformation if it is inside parentheses. That is a horizontal translation. It is actually the opposite of the sign you're given. So if it's x plus h, that is a transformation to the left, and you're subtracting from your x value. If it's f times x minus h, it's a transformation to the right. And then you would be adding to your x value. And so keep in mind that if it is in parentheses right here, it is going to be the opposite of the sign. So again, if it is a plus, that is a minus h, meaning you're translating to the left. If it is a minus, you're translating to the right, that would be plus. So parentheses, opposite sign, and opposite transformation. Next, if your negative sign is in front of your f of x, that's a reflection over the x-axis. If it is inside the parentheses, that is a transformation over the y-axis. If you have a number in front, so if your a right here, if your a or absolute value is greater than 1, it is a stretch, so it is the function is more narrow. If the absolute value of a is between 0 and 1, it is a compression, so it's wider. And if you have, if you're b, if it's inside of your parentheses, if your b is greater than 1, that is a compression. If your b is less than 1, I'm sorry, in between 0 and 1, that is a stretch. And here we're referring to an exponential function where you have your b. All right, so let's get started. So looking at example 1 here, it says describe how k affects the graph of the function f of x is equal to 2 to the x power in each of the following situations, and we're going to assume that k is greater than 1. So part A, we have f of x minus k, that is on the outside of the parentheses, and so that would be just shifted k units down. Part B, that is inside the parentheses, so remember it's going to be the opposite, so that is shifted to the left. All right, and then we would subtract k units from our x value. And part C, k times f of x, that would be the graph is vertically stretched by a factor of k. All right, so now let's move on. All right, so let's take a look at examples 2 and 3 here. In our next few problems, we're going to consider the function, the exponential function, f of x is equal to 2 to the x power. And in each one, we're going to write a function to represent the transformed function using g of x and describe the transformation. And so right here, our first one, we have negative f of x. So in terms of our transformed function, g of x is equal to 2 to the x power, because we're considering this function here. So 2 to the x power, and that would be a negative in front because we have a negative in front of our f of x. And if you can recall from our overview of transformations of functions, that negative is in front of the f of x, and so that graph will be reflected over the x-axis. So it's flipped over the x-axis right here. All right. Next, example 3, that is inside the parentheses. So when we write our function, that's going to be a horizontal transformation, and that would be g of x is equal to 2 to the x power plus 3. That plus 3, or 2 to the x plus 3, would be in as a part of our exponent, because that would be a horizontal transformation of our x values. The description would be the graph is shifted 3 units to the left So this graph shifted 3 units to the left. All right, so let's take a look at these two examples. We're considering the same function, and once again, we want to write our transform function and a description. And so, again, we have inside the parentheses, and so that transform function in terms of g of x would be 2 to the x minus 3. The description is that graph is shifted 3 units to the right. So shifted this way here. And example 5, outside of the parentheses, so our new function, or our transform function, would be g of x is equal to 2 to the x power minus 3. So not in parentheses. That description here would be the graph is shifted 3 units down, so it went down from our graph of 2 to the x power. All right, so for example 6 and 7, I would like for you to try these on your own. So go ahead and pause the video and try these problems on your own. All right, so check your answers here. You should have gotten g of x is equal to 2 to the x power plus 3, not in your exponent because that is outside the parentheses. And here we have a vertical stretch at the bottom, so that 3 should be in front. So go ahead and pause the video and just check and analyze your work here a little bit more. All right, so let's take a look at example 8 here. It says, given a graph of f of x is equal to 2 to the x power, describe the graph of f times x minus 3 plus 2, how that would compare to the graph of f of x. So inside the parentheses here we have a minus 3. So since that's inside the parentheses, that would be a horizontal shift, left or right. Since this is a minus, it would be shifted to the right 3 units. And this 2 here is our vertical transformation. That is a positive 2 plus 2. So that would be translated or shifted 2 units up from f of x. So inside the parentheses, again, would be our opposite sign. So a minus would be to the right. And then outside of the parentheses here, since that is a plus 2, that is up 2 units. Let's take a look at example 9. It says the graph of the function f of x. F of x is a transformation of the exponential function. G of x is equal to 2x plus 1. Write the exponential function for the graph. And so the graph of 2 to the x power is right here. That has a y-intercept of 0, 1 right here. So hopefully you can see it. All right, so looking at the function g of x here, since we see that plus 1, the g of x is translated 1 unit up from our parent function here of 2 to the x power. So it would be translated up. So the new y-intercept would be at 0, 2. So now writing a new function for this graph here. So if g of x is right here, the y-intercept is here. To get from here to here, we have to count down 1, 2, 3, 4 places. So that graph went down 4 units. So we would subtract 4 from this positive 1 here. So 1 minus 4 gives us negative 3. So our new function here would be f of x is equal to 2x minus 3, or 2 to the x power minus 3. So for our last problem here, it says consider the function f of x is equal to 1/2 to the x power. Describe the graph of each transformation. So for each of these problems, you have 5 here. Just describe the transformation, whether it's shifted up or down, left or right, whether it's a stretch or not. So go ahead and pause the video and try these problems on your own. Alright, so I have the answers here. Go ahead and pause the video and check your answers. Hopefully you got them correct. If not, keep it paused for a little longer and analyze the answers here just a little bit more. Alright, so we've reached the end of our lesson. I want to thank you for learning with me. Some related videos are constructing exponential functions and exponential growth or decay. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.